Hello children. So welcome to AIMS India's online classes. Today from math subject rational number topics we are going to learn. So in our previous video we have learned some basics regarding the rational numbers. So the definition of rational numbers, equivalent rational numbers, like that some basics we have discussed. And comparison of rational numbers, method 1 we have discussed. So in continuation to it, in today's video, let's see the comparison of rational numbers in method 2. In method 2. So here, if AB are integers and CD are positive integers, then we can have three cases. We can compare according to these three cases by using this kind of multiplication. Here, suppose if we have A by C and B by D, two rational numbers are there. By cross multiplying A with D, B with C, what products we will get? One is AD, another one is BC. Just by comparing the product of AD and BC, we can compare the fractions. So in method 2, what we are doing? So whatever fractions we have, that fractions we are making them cross multiply. But here condition is applicable. AB should be integers and CD should be positive integers. Why CD positive integers? Because CD are in denominator part. So this is applicable for positive denominators. In that case, if we multiply AD and BC, cross multiply, then with the help of this comparison, we can compare the given fractions. If AD is greater than BC, so then A by C will be greater than B by D. So very simple. If AD is less than BC, then A by C is less than B by D. If AD equal to BC, then A by C is equal to BD. Means after cross multiplying, the product in what way it is behaving, in the same way the rational numbers also behaving. Okay, like this in method 2 we can compare the given rational numbers. So next. So for example, if I have 9 by minus 11 and 5 by minus 17, suppose this is there, this problem is there. In this problem, what we are doing? We have 9 by 11. They have given one fraction, 9 by 11, another fraction, 5 by minus 17. But what is the condition here? The denominator to be positive. So we take minus symbol upwards, it will become minus 9 by 11. Here also minus symbol upwards, it will become minus 5 by 17. So we have expressed the given fractions with positive denominator. After that, we have to cross multiply according to method 2. 9 17s are how much? 153. Minus 153. Minus 5 11s are how much? Minus 55. So here minus 153 is less than minus 55. Why? For negative integers, greater the number, lesser will be the value. So minus 153 is less than minus 55. So the given fraction minus 9 by 11 is less than minus 5 by 17. Or minus 9 by 11 means we can write 9 by minus 11 in the form of given rational number. So these are less. So like this, with the help of cross multiplication in method 2, just by comparing the product of AC and BD, we can compare the given fractions. We can compare the given fractions. Okay, children? This is the comparison of rational numbers, method 2. Method 2. So next. So after comparison, what we can do? After comparing the given rational numbers, we can arrange them either in descending order or in ascending order. We can make them arrange. So first we have to compare. After that, we can arrange them according to whatever order we want. Now, here they have given a question. They have given 3 rational numbers and they are asking us to arrange them in descending order. To arrange them in descending order. So how? First what we have to do? First we have to write each with a positive denominator. That is first case. Then we have to take LCM. LCM of the denominators. That is second step. LCM we will take. Next, all the fractions to be written in terms of LCM. The denominator in terms of LCM. So like that we can compare. So let me repeat once again. So in the question they asked us to write in descending order the given fractions to be written in descending order. So what we have done? We have taken we have written first step with the positive denominators. The minus symbol we have kept upside. Then what are the denominators here? 5, 15, 3. For the 3 denominators, we have to take what? LCM. We have to do LCM. So what is the common factor here? 5. 5 ones are, 5 threes are 15. 3 will be like that only. 133 is there. Next we will prime factoration we will do with 3. 3 ones are, 3 ones are, 3 ones are. So here 1 means downside we will write 1 only. 3 ones are, 3 ones are. So what is the LCM? 15 is the LCM. 15 is the LCM. So what we have to do? We have to write denominators in terms of LCM. So denominator here 5 is there, but we need 15. For getting 15, what we have to do? We have to multiply both numerator and denominator with 3. With 3. So 5 3s are 15, 4 3s are 12. This is the first fraction, first rational number. So what we will get? Minus 12 by 15. Second fraction, the given second fraction is minus 9 by 15. So already in denominator part 15 is there. So no need to worry. We can keep like that only. Third fraction, minus 2 by 3. In denominator part 3 is there. How to make it into 15? Multiply with 5. Multiply with 5. 3 5s are 15. Numerator part also to be multiplied with 5. 2 5s are 10. So we got minus 10 by 15, which is the third rational number. Minus 9 by 15, which is second rational number. Minus 12 by 15, which is third rational number. Now all the 3 rational numbers having same denominator. Same denominator like this. Now we can compare them. Now we can compare them. Which one is greater? What they are asking? They are asking to write in descending order. So greatest value to be written first. Out of here what are the numerators? Minus 12, minus 9, minus 10. These 3 are the numerators. Which one is largest? If we have minus symbol, lesser value will be the greater value. So minus 9 by 15 will be the largest. Next minus 10 by 15. Next minus 12 by 15. This is the descending order. We can write them in terms of original fractions like this. Original fractions like this. So what we can do? So after comparing the rational numbers, we can write them in descending order or ascending order. For comparing them, what we have to do? We have to take first step is we have to make them with positive denominator. If in denominator minus symbol is there, we have to take it up. That is first step. What is the second step? For denominators, LCM we have to take. That is second step. After taking LCM, all the denominators to be multiplied with some number so that LCM will be the denominator. LCM will be the denominator. After that, we can arrange them according to our order. Okay, children? This is about writing the given rational numbers in descending order. So, okay. Next. Okay, children. Let's see another concept of rational numbers, which is absolute value of a rational number. Actually, for a rational number x, it may be greater than 0 or equal to 0 or less than 0, but the absolute value is always non-negative. So here the absolute value of 5 by 7 will be equal to 5 by 7. Absolute value of minus 12 by 9 is equal to 12 by 9. Absolute value of 0 is equal to 0. So, like integers, it behaves like absolute value of integers. Actually, regardless of its sign, absolute value of a rational number is written as modulus of x. Regardless of its sign. We may have minus x or plus x or anything, but its value always non-negative. Like 5 by 7, 12 by 9, 0. Its value is always non-negative. Okay, that is one thing. So next. So let's see some examples. So find the absolute value of. For all these values, we have to find the absolute value. So A, B, C, D, 5 questions are there. We have to find the absolute value. So absolute value here. So how can we find here? The absolute value of 7 by 11. How much? 7 by 11 only. Here minus 15 by 7. For numerator part, a negative sign is there, but absolute value means it is always non-negative. So this negative value, negative rational number, after taking the absolute value, it will become positive. Here in C example, they have given a product of two rational numbers inside a modulus symbol. So minus 1 into 7 or minus 1 by 3 is there, 7 by minus 3 is there. Here minus 1 by 3 is okay. This minus part, we are keeping it up. It will become minus 7 by 3. After multiplication, minus 1 into minus 7, it will become 7. 3 3 is 9. So the modulus value of 7 by 9 is 7 by 9. 7 by 9. Like that. So next. So here, 1 minute. Here children, D example. Here they gave division symbol. Minus 5 by 4 divided by 35 by 16. 35 by 16. After simplifying it, we have to find the modulus value. How to make it simplify? If we have two rational numbers and division symbol is there, division symbol we can write it as into symbol and we can reverse the fraction. 35 by 16 we can write it as 16 by 35. 16 by 35. After cancellation, because 5 7s are 35, 4 4s are 16, we will get minus 4 by 7, which is equal to 4 by 7. which is equal to 4 by 7. So next, which is equal to 4 by 7. Next one. Here subtraction symbol they have given. Subtraction symbol they have given. So we have to take their LCM and we have to subtract what we have got, minus 3 by 6. So means after simplification we will get minus 1 by 2. The absolute value is 1 by 2. So you can have any kind of rational number. It may be a sum, it may be a product, it may be a quotient, it may be a difference, it may be a sum, or it may be a single rational number. So after simplifying, if you take the absolute value, it is always a non-negative rational number. Non-negative rational number. Okay children, that is about absolute value. So regardless of the sign, its value is always non-negative. Next. So compare. So here in this question, we have to compare the absolute values. In previous examples, we have compared normal rational numbers, but here we have to compare the absolute values of the rational numbers. Absolute values of the rational numbers. Okay, so what we have to do? Absolute values of the rational numbers we have to compare. 1 minute. So here, this is the first one, minus 4 by 3 plus 5 by 8. We can take LCM 24. We can simplify it. 3 8s are 24. 8 4s are 32. We got 32 here. 8 3s are 24. 3 5s are 15. We got 15 here. Minus 32 plus 15. Minus 17. Modulus value 17 by 24. So for the first rational number, the modulus value is 17 by 24. Second one, same rational numbers only, but separate modulus they have given. In the previous example, after adding them, they gave modulus symbol, but here modulus symbol given, after that they are adding. So minus 4 by 3, 4 by 3, 5 by 8, 5 by 8, we can take the LCM. So what we will get? 47 by 24. 47 by 24. So please be careful children. Be careful because here both of them they are different. The given fractions are same. Given fractions are same. But both of them they are different. Here for first they have added them. Then they have given the modulus symbol. But here first modulus symbol given. After that they are added. That's why two values we have got different. Two values we have got different. Okay. Here also denominator 24. Here also denominator 24. We have same denominator. We have same denominator. So that's why 47 by 24 is greater than 17 by 24. So this modulus value is greater than first modulus value. Like that we can compare the modulus values also. We can compare the modulus values also. Okay children. Here the question is find two rational numbers whose absolute value is 1 by 3. Whose absolute value is 1 by 3. So the absolute value should be 1 by 3. Absolute value should be 1 by 3. So here absolute value 1 by 3 means what for what values it is possible? Inside the modulus we can take minus 1 by 3 or inside the modulus we can take 1 by 3. For both the values absolute value is 1 by 3 only. So means we have two rational numbers like 1 by 3 and minus 1 by 3 whose modulus value is or absolute value is always 1 by 3. They are two equidistant from the number line. If we have the number line, if 0 is here, one side we will be having 1 by 3, another side at equal distance we will be having minus 1 by 3. Both are at equal distance from the origin. Both are at equal distance from the origin. So, for absolute value, two different values will exist. Two different values will exist. So, okay, children. Now, let's learn about number line concept. So, we have seen comparison concept. Next, absolute value. Next, how to represent these rational numbers on the number line. Already we know how to represent integers. Already that we know. 0, we will take 0 in the middle. Right side we will have positive integers. Left side we will be having negative integers. So now rational numbers. We have to know how to represent rational numbers which are in the form of p by q, where p is less than q. Where p is less than q. Let's see with examples. So here we have to represent 2 by 5 and minus 2 by 5 on the number line. 2 by 5 because here, sorry children, here minus is mixed with that. 2 by 5 and minus 2 by 5 on the number line. Okay, now how to represent on number line? Let's see first. So what we have to do? So first we have to write a number line with 0, 1, 2, 3. Here also minus 1, minus 2, minus 3. With that we have to draw a number line. So what they are asking? 2 by 5 they are asking. Means 2 parts out of 5 parts. 2 parts out of 5 parts. So what we will do? So here we have 0. 0 is there. Left side, right side 1, 2, 3 we have. Left side minus 1, minus 1, minus 2, minus 3 we have. What we will do? The place between 0 and 1. The place between 0 and 1, this part 0 and 1 means this part is divided into 5 equal parts. Is divided into 5 equal parts. Which part? The distance between 0 and 1. Here we have 0, here we have 0, here we have 1. This distance is divided into 5 equal parts, and at 2 parts we have marked a point A. We have marked a point A here. We have marked a point A here at second part. So it is equal to 2 by 5. It is equal to 2 by 5. As 2 by 5 is a positive rational number, so we have taken right side part to the 0. For representing minus 2 by 5, what we have to do? We have to take the left side part of 0. Left side part of 0. We have to take left side part of 0. Left side part of 0 we have to take. So means here 0 to 1, 0 to minus 1. 0 to minus 1, whatever distance is there, it is divided into 5 equal parts. 5 equal parts. And second part, out of 5 parts, second part is represented with the symbol B. Represented with the symbol B, which stands for minus 2 by 5. It's very simple, children. 2 by 5 we have to represent on a number line. So what we will do? From 0 to 1, whatever a part is there, because 2 by 5, we have told already, p value q is less than, p value 2 is less than q value 5. So its value is always less than or equal to 1. Less than or equal to 1. So that's why the place between 0 and 1 is divided into five equal parts. Out of that, at 2 parts, we have kept A, which stands for 2 by 5. Minus 2 by 5 also towards left side, the place between 0 and minus 1 divided into 5 equal parts, and the second part is kept as B, which is equal to minus 2 by 5. Like this we can represent numbers on the rational numbers on the number line. Okay. So next, suppose if you want to represent a rational number of form P by Q, where P greater than Q, if numerator value is greater than Q, so then its value is greater than 1. In that case, how to represent rational numbers on the number line? So previous example, numerator part is less. So that's why below 1 value, its value will be below 1. So that's why we have divided place between 0 to 1 into some equal parts. But if it is greater than 1, how to represent, that also we have to learn. So here 14 by 13 minus 14 by 13, we have to represent on the number line. So what we will do? First, we will change them into mixed fractions. So after changing them into mixed fractions, we represent them on the number line. Let's see this example, children. So here 14 by 3 is there. After changing into mixed fraction, what we will get? 4 2 by 3. Minus 14 by 3 is there. Minus 4 2 by 3. 4 2 by 3, no need to worry. No need to bother about 4 2 by 3. But minus 4 2 by 3, how to write? Minus, we will take it out common. Inside the bracket, we will write 4 plus 2 by 3. Again, if we expand it, minus will come for 4 and minus will come for 2 by 3. It will become minus 4 plus minus 2 by 3. So first, let's see 14 by 3 or 4 2 by 3. How to represent on the number line. So what we have to do? Start from 0 to 4. We have to take full units. So 0 to 4. 0 to 4 we have to take full units. After 4, because we have 4 2 by 3 here, means the value is more than 4. How much more than 4? 2 by 3 parts more than 4. So after 4, between 4 to 5, this part to be divided into 3 equal parts. And 2 parts. At 1, 2. At second part, we have to keep P. Where after 4, after crossing 4, between 4 to 5, we have to take 3 divisions. And second division from 4, we have to take it as P. So that represents 4 2 by 3. Means 4 complete parts plus 2 by 3 part. 4 complete parts plus 2 by 3 part. So that is representing of P by Q, where P is greater than Q on the number line. In the same way, if you want to represent minus 14 by 3, same process we will follow on the left side. Up to minus 4, we have to count full parts. 0 to minus 4, full parts we have to count. Between minus 4 and minus 5, we have to make 3 equal parts, and second part to be termed as Q. Second part is named as Q. So that stands for minus 14 by 3. So in this way, we can represent rational numbers on the number line. Okay, children. So next. order relation. Order relation. So here in order relation we have to follow some points. Two equal rational numbers. So on the number line we have to follow some order. What is that order means? Two equal rational numbers always correspond to the same point. On the number line they will be represented with the same point P or any other name if their value is same. If P by Q lies to the right of R by S, because it is on the right side of R by S, P by Q value will be greater. If P by Q lies to the left of R by S, P by Q value will be lesser. All rational numbers lying to the left of 0 are negative. To the right of 0 are positive. This order relation we have to follow. Equal value, same point. If P by Q lies to the right, it will be greater. If P by Q lies to the left, it will be lesser. To the left of 0, all are negative. To the right of 0, all are positive. Like this we have to take the order relation. Okay children, let's solve some fill in the blank questions based on the present concept. So here 5 fill in the blanks questions are there. Let's try to solve them. So what is the first question? 7 by minus 8 expressed as a rational number with the denominator 24. So here first thing is, so whenever you have negative denominator, first you have to make it as positive. Minus will go upside. It will become minus 7 by 8. Now what we need? We need denominator 24. How to get 24? 8 to be multiplied by 3. 8 3 times 24. With the same number we have to multiply denominator. Already minus is there. 7 3s are 21. So what is the answer? Minus 21 by 24. That is the answer. So next. Minus 4 by 7. We have to compare 4 by minus 11. We can take minus upside. It will become minus 4 by 11. One is minus 4 by 7. For comparing, what we need? We need same denominator. So 11 and 7, LCM how much? 77. We have to multiply with 7 here. So it will become 4 7s are. What it will become? 28 by 77. Minus, here we have to multiply with 11. So that denominator will become 77. With 11 we multiply means what we will get? Minus 44 by 77. Here denominator part is same. Minus 28 minus 44. Here lesser value will have greater value because of minus sign. So what we can write? The first fraction is greater than the second fraction. Like that we can make the denominator equal and we can compare the numerators. Okay children. Next, third question. Next third one. What is the absolute value? What is the absolute value of minus 16 by 19? So absolute value means it's very simple. Without considering any sign, it will be always non-negative. Minus minus cancel. 16 by 19 we will get. Absolute value of 16 by 19 is equal to 16 by 19. 16 by 19. So what is the fourth question? The rational numbers whose absolute value is 11 by 13. So what are that numbers? One is minus 11 by 13. Another one is 11 by 13. For these two values, absolute value is 11 by 13. We can take minus sign without minus sign. These two are the rational numbers. Next, last one. The rational number which is neither positive nor negative. So what is the answer? 0. Because 0 is neither positive nor negative. Okay, children? Next. Some true or false. Okay, children. Regarding this, we can discuss later. Okay, children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you.